We're also going to talk about how we can use the second derivative to help us find absolute extrema. But before we can do that, we need to talk about the second derivative test, which helps us determine local extrema. So if we have c is a critical number and f prime of c is equal to 0. So this is only going to work for us if we have a horizontal tangent line. If f prime of c is undefined or f prime of c does not exist, then the second derivative test is not going to work for us. Then we need to fall back to the first derivative test. If the second derivative is greater than 0, so if f double prime is positive, then f of c is a local minimum. And on the other hand, if f double prime of c is less than 0, so if the second derivative is negative, then f of c is a local maximum. So we can draw out a few cases here. Notice in all of these cases, again, the first derivative at c has to be 0. This will not work if your first derivative is undefined at c. If f double prime of c is positive, in that case the graph, what do we know about the graph? Well, the second derivative is positive, so that tells us that the graph of f is concave up. So that must mean that f of c is a minimum. And if you have trouble visualizing this, draw something which is concave upward. Draw the picture of a graph which is concave upward. Say, okay, here we said f prime of c is 0, so that's where we have that horizontal tangent line. So yeah, this point right here, oops, let me highlight it, this point right here is a local minimum. If we switch the sign on the second derivative, so now f double prime of c is negative, then we know in that case that the graph of f is concave down, so we must have a maximum. And I should say for both of these are local minimums and local maximums. So again, draw a picture of the graph which is concave downwards. So okay, here's the graph. Oops, that's not very good. That's still not very good. There's the graph of something which is concave down, and there we have our absolute, or not absolute, our local maximum. It may be an absolute maximum, but we know at the very least, it's a local maximum. The one case we didn't talk about is if f double prime of c is 0, and this case is a little bit tricky. The graph of f is, well, we don't know. F of c, we don't really know what that is. In that case, we need more information. More information is required. Because maybe it's a maximum or a minimum, but perhaps more likely than not, my guess is you have an inflection point there. So then in that case, it would be neither a minimum or a maximum. If the second derivative is 0, then you would need to go back and double check with your first derivative test. Unfortunately, this is one of the shortcomings of the second derivative test, is that if your second derivative is 0, we actually can't draw any conclusions. We don't know what that looks like.